Hello, thank you for watching this video. So now we're doing the last question of trigonometry, which is the application or 3D application of trigonometry. As you can see the drawings here. So they're saying point B, C, and E lie on the same horizontal plane. A, B, C, D is a rectangular box. C, D, E is a triangular piece of board having a right angle at C. Each piece of the board is placed perpendicular to the horizontal plane and joining along DC, as shown in the diagram. The angle of elevation from E to D is x. Angle E formed by BE and EC is equal to 2x. And angle B formed by line segment EB and BC is equal to 30 degrees. So let's try to read this thing again. They're saying points B, C, and E lie on the same horizontal plane. A, B, C, D is a rectangular piece of board. They are saying CDE is a triangular piece of board having a right angle at C. Each piece of the board is placed perpendicular to the horizontal plane and joined along DC as shown in the diagram. They are saying now, the angle of elevation from E is D, and angle E formed by BE and EC is equal to 2x, and angle B formed by EB and BC is equal to 30 degrees. So let's have a look here. They're saying B, C, and E are points on the same horizontal plane. So they form the surface or the base of whatever that they are doing. So the part that I'm shading out is these are 3 points forming a triangle along a horizontal surface. So if you have a horizontal surface here, you can say this is A, or this is B, E, and C. They're all along the same horizontal plane. They went on to say that A, B, C, D is a rectangular box, right? So you know a rectangle, right? If you have a rectangle, this side is equal to this side, and this side is equal to this side. So the opposite sides of a rectangle are equal. And you know that this side is parallel to this side, and this side is parallel to this side. So you know that rectangles are parallelograms. So these are the features that we have. Right? No problem. They're saying now, CDE is a triangular piece of board having right angle at C. So they're saying CDE is a triangular piece of board that has a 90 degree over there. Right? And since this is a rectangle, so all of these angles are 90 degrees. You know them. So they went on to say each piece of board is placed perpendicular to the horizontal plane. So since this one BCE is horizontal like this, so this one is placed vertically so that it's perpendicular to this one, and that one as well is also perpendicular. So they're telling that this board is placed perpendicular to this BC of the horizontal plane, and this board as well, which is your DE, your CE, is the base of CDE, and this triangle also is placed perpendicular to the surface. So this is 90, this is 90. That's what they're saying. And yeah, and then they give you the angle that this is 18, this is 2x, this is x, 90, and all the other stuff. So at 7.1, what are they saying at 7.1? They're saying show that DC is equal to this. So they want us to show that DC is equal to this. What is DC? DC is this length over here. This is DC. They want us to find this length over there. So how can we go about this? If you look at DC is on this rectangle, right? And at the same time, DC is on this triangle CED or CDE, right? So we can try to find DC on this triangle. We have an angle. On this side, we have an angle. We can also maybe try that side as well. So we can say, okay, sine of that angle E over there. How did they write it? Sine of B is C. So this is angle E, which is this angle E of yours formed by line BE and EC. Angle E is formed line BE and EC. So which is not? No, it's not. So because we want to use this angle on this triangle. So let me be specific about which triangle I'm working in. So in triangle CDE, we can say now the tangent, which is tan of this angle here. So it's angle E. How do you write this angle E? Angle E is formed by line segments CE and ED. Angle E is formed by CE and ED is equal to, you know, the tangent is equal to the opposite side over the adjacent side. The opposite side is DC over the adjacent side, which is what? Which is CE. So in that case, we can say, okay, the tangent of angle E, which is X, is equal to DC, which is what we want, over CE, which you don't have. We don't know what CE is. So, yeah. So we can say, okay, DC now, okay, we can cross multiply. Say, okay, CE tan X is equal to DC. We've solved for DC now. So this is our DC. But this DC of ours is not this. Right? It is not that. So we want DC to be like that. Okay. So since we have DC over there, how about we try to find CE? Because we want DE, we want DC. So DC is fine here. So let's try to find CE and see if anything could happen. CE lies on this triangle, which we've already used to get this. And CE also lies on this triangle, which is the basal triangle. Right? So if we look at the base triangle, triangle BCE, and say, okay, in triangle BCE, which is on this triangle over here, triangle BCE, we can say, okay, we can apply, because we want this, right? We want this side CE that we can substitute over there. But if you look at DC that you're looking for, it also contains BC. So you want to find this side, and this side should be involved on the final product. So what connects this side and these two sides is the sine rule. So if you look at this triangle, you can say, okay, you can apply your sine rule and say, okay, if you apply the sine rule, this is E, right? So this will be small e, this is B, this is small b, C, this is smaller c. So in that case, because we want to relate these two, we'll say small e over sine angle E, is equal to what? It's equal to B over sine angle B. This is the sine rule. This is the sine rule here. So what is your E? Your E is your BC over your sine E. Your sine E is sine 2x over here, equals B. What is your B? Small b. Your small b is CE, which is what you have there, all over sine B. What is your sine B? Your sine B is equal to sine of 30 degrees. So we can simplify this and say, what? And say BC over sine 2x is equal to CE over the answer to this, which is 1 over 2. Then you can cross multiply. If you cross multiply here, you find that your CE, this time this time that, oh, you'll get that your BC times 1 over 2 is equal to what? This times that, or your CE times sine 2x. So divide by sine 2x, divide by sine 2x. So what you get that your CE is equal to what? Is equal to BC BC, right? all over 2 sine 2x. That's what you have. So this is your CE. So your BC over 2 is this one. And then you divide by 2x, there you will go. So in that case, we take this CE and put it back there. So what we'll get is your BC, you said your DC is equal to CE times the tangent of x, right? Yes. So we know the CE. CE is this. So DC is equal to your CE, which is BC, all over 2 sine 2x times the tangent of x. In that case, your DC is equal to your BC times all over 2. What is this? You know this is a double angle. This is 2 cos theta. Oh, this is 2 cos theta, cos x sine x times this. What is that? That is sine x over cosine of x. That case, this and that will cancel out. Your DC is equal to BC all over. Then you multiply this, and that. So this and this is 4. This time that, so you have 4 cos squared x. So that's how it goes. So here you just need to remember the double angle formula identity for that, which is this, and the 2 is still out there, and we're done with this one. So we're going to go to 7.2. Hopefully 7.2 will fit here. So if x equals 30 degrees, show that the area of ABCD is equal to what? 3AB squared. So they're saying if our x is equal to 30 degrees, we must show the area of ABCD to be that. What is ABCD? It's a rectangle, right? So the area of ABCD is equal to length times breadth, right? Our length is what? So our area of ABCD, our length is AB. Let's say it's BC, right? Let's say it's BC times breadth, which is this side or that side. Let's say AB, because we're trying to have AB at the end of the day. It's BC over times AB. This is the area. So I've said length times breadth. So BC times AB. That's our area. So now I'll say we need to go and find what BC is, because AB is okay. We're trying to have another AB here so that we can have an AB squared. So we're trying to find a 3AB. We're trying to show that BC is equal to 3AB. So let's go to BC. We just prove that BC, just show that DC is equal to BC over 4, for what? For cos squared x. But because x is equal to 30, you can say BC is equal to 4 cosine of 30 all squared, right? And this is BC over, so 4, what is this? So this is square root of 3 over 2 all squared, right? So your DC is equal to BC over 3. But remember, BC, remember that DC is equal to what? DC is equal to AB. Why? These are opposite sides of a parallelogram or a rectangle. So we can say, in this case, instead of having DC, we can say AB is equal to BC over 3. But we have BC here, so let's solve for BC, which is your BC is equal to 3AB. So which means your area here is equal to your BC, which is 3AB times AB. So which means your area is 3AB whole squared. So that is what they wanted us to show. And I hope this does make sense to you, as it does to me. So we're done with trigonometry. We're going to go to the next question, which is the beginning of the Euclidean geometry. So let's go and do the Euclidean geometry and be done with this question.